Hi, everybody. Thanks for joining us today with the Cleveland AWS user group. We're excited to have Jeremy Snyder here today, who is going to talk about the double-edged sword that is AI. Welcome, Jeremy.
Thank you, Kathy. Happy to be here.
Thanks. So we've got special guest Brian Tarbox. Brian works for Kalent. He runs the Boston user group. AWS hero, quite well known in the community. Good seeing you, Brian. Thanks for coming.
Always good to be here. I'm really looking forward to this talk.
Thank you. And for anyone who doesn't know me, I'm Kathy Clark. I work for Rhythmic Technologies. I run the AWS Cleveland and the DMV user groups. So glad to have you here, even after the fact. And I'm going to turn it over to Jeremy.
Awesome. Thank you, Kathy. So, just a little bit about myself as I get into this talk. I have been working in IT since 1998. I spent the first half of my career as a kind of hands-on keyboard practitioner, worked my way up through cyber and IT back at a time when those were not really separate functions the way that they are very often today. If you were an IT person back then, cybersecurity was part of what you did, and that was true for myself and most of my peers at the time. I've been through uh, two major data breaches in my career, as well as a number of kind of virus incidents. So I do have some firsthand battle scars, so to speak. But really, I kind of changed my career focus from being a practitioner into being more of a solutions architect and helping customers solve problems, starting with my time at AWS all the way back in 2010, back when telling people about the cloud was often answering questions like, why is a bookstore trying to rent me servers? And answering other questions about like, oh, Amazon bought too many servers, you're trying to rent us spare capacity. We got all of those things. But I've really stayed in the cloud ever since. I spent some time with a company that did large scale cloud migrations. I also worked at a cloud security posture management company called DivvyCloud, where we grew very rapidly over a 4-year period before getting acquired by Rapid7. And I started Firetail with my co-founder Riley in 2022. We started Firetail to address the problem of API security, and maybe time permitting, we can get into some of that, but that's not really what I'm here to talk about today. I wanted to share a thought process that I've been working on for a little while now, and it really started with the question of why is it that every time there is a fundamental new technology that delivers a lot of value, it always comes with security challenges for organizations? And that was really kind of the high level question. And part of it is, why do we get things wrong? Why do we have disconnects and so on? But I wanted to kind of frame it around the question of AI because that is the latest in this waves of new technologies that is bringing the same problem to bear. And so I'm going to talk about kind of how organizations adopt new technology, what are some of the patterns that we tend to see, and then what are some of the challenges that come along with those adoption patterns. And then, with AI, there's a lot of hype and a lot of it is real. This is a technology platform that is already delivering results for a lot of organizations, but it comes with some risks and some downsides as well. Other than that, we'll kind of go through things and hopefully have a good amount of time for questions at the end. So I myself have been through kind of 4 waves of technology change during the course of my career. And what I've noticed is that every time we have new technology, it comes with what I call first-party risks and third-party risks. First-party risks are kind of the things that are within your control. So if you think about, let's say, the first wave of new technology that I lived through, that was actually just the adoption of desktop computers all throughout an organization. And let's say things like having a small local network, a LAN, right, within an office environment. And we all had versions of Windows, and those versions of Windows had vulnerabilities, and Windows patches were available, right? And so this was the really what I would say the introduction of kind of vulnerability management and CVE, if you're familiar with that acronym, common vulnerabilities and exposures. Those CVEs are pretty much within our control, meaning that we have the ability to patch CVEs. We may not be very good at it as an industry. I think the stat for the mean time to remediation of a CVE has been around 180 days for something like 20 years now, and it hasn't really improved over the 20 plus years that I've been in IT. But the point is that that's something that we control. And so, first party risks, when I say that, what I mean is the risks that are things that we're in charge of. And then when we moved to the cloud, what we actually saw was a bunch of misconfigurations. And we'll talk a little bit about some of the examples there. But that's again an example of something that is within your control. I'm sure everybody who is here or who's watching this video is familiar with the shared responsibility model. And if you talk to AWS, what you're going to hear, they're responsible for the security of the cloud, and you are responsible for your security in the cloud. So the security of your organization or your AWS footprint is a first party responsibility, and then any misconfigurations are a first party risk. And as we kind of, let's say, got more advanced in the cloud and we started doing microservice architectures and we started having APIs everywhere, we've repeated the same thing. The design of the API and the design flaws of the API are first party risks. You're in control of them. You built the API, you own it, you run it, you manage it, you're responsible for it. But you combine this with third-party risks. And again, like every new technology platform brings some of those risks. So we adopted desktop computing all throughout the organization. Well, guess what? Threat actors wrote viruses, right? And this was anything from the simplest little worm down to malware and information stealers that we see today. Second is things like DDoS. This is something that an attacker can do to take your footprint offline. And this has been, DDoS has been a thing for well over a decade and a half at this point. Fun little side anecdote I can tell you from my time at AWS, one of the things that we would get from customers, especially in Asia, was that DDoSing was actually seen as kind of a legitimate business strategy. If your competitor was running a big sale, it was very much within scope to go hire somebody to DDoS your competitor and try to affect their sales numbers and bring them over. And I heard time and again from customers, oh yeah, I'm getting DDoSed right now. Can you help us with some, I don't know, CloudFront to, keep our content online, things like that. Scraping, similarly, as we saw, as organizations started to put more and more of, let's say, their product catalogs online, we actually saw a wave of bots going out there and stealing information about product catalogs and offering and price comparison engines and all those types of things that are actually kind of taking data off of your site. And the common thing that I say here, you'll notice is, if something is online, it will get attacked. And so that is a third-party risk that kind of comes along with putting something online. So overall, bots are responsible for a lot of that stuff, but you can see them as an element of third-party risks. And we're seeing some new third-party risks around AI, and we're going to talk about some of that. So I really view the four waves of technology transformation that I've lived through as being kind of the early on-prem, right? So we started out by having all of our stuff in an office, in a data center, in a colo facility, whatever. And, I think about kind of the late 90s, 2000s time period as being the golden age of this technology model. And if you came online at any point from, let's say, like 95 all the way up to like 2010, 2011, this was primarily how you got it done. You got your own server facilities, etc. The other thing to note about that time period is that if you wanted to do something, you wanted to put something online, you had to go through somebody. Most organizations, you couldn't just do whatever you needed to do. You needed to go get approval for that. I've talked to a lot of people over the years, and they had this whole workflow around requesting a virtual server and then waiting 3 months for somebody in IT to actually approve and provision it for them, right? And also, a lot of the defense strategies around that time were oriented around kind of controlling the perimeter. Let's just keep bad actors out of our environment, and we'll be good. And so if you think about the tooling that was used at that time, very firewall focused, WAFs kind of came at some point during that time, but it's really focused around, like, again, keeping bad actors out. And so if you think about kind of the risks and the types of breaches and attacks that we saw during that time period, you had things like Equifax, where it was actually a web application owned by Equifax, where they didn't go through the steps of validating inputs against a SQL injection attack. And so I categorize that on the first party risk side. They controlled the server, they controlled the application, they controlled all components around it. They are responsible for making sure that that web application is validating properly and not allowing SQL injection that allowed access to those 147 million records. At the same time, we had kind of the third party risks of things like the I love you virus, which I lived through a number of times because inevitably, once we cleaned up for it, somebody would come back from vacation and launch the whole process again. And dating myself a little bit, but it was miserable every time. Thankfully, it was relatively harmless on the scale of attacks. But things like Worm32 Configure, which took advantage of a of a vulnerability within the Windows operating system, and I can't remember what specific DLL it exploited. It's something like the Windows Messenger, if I remember right. But that was basically a pop-up malware that could use a UDP port to get into your network, right? And so that's a cyber attack coming from an outside party, third party risk. And then we move into the cloud, and kind of just to continue illustrating some of my points around first and third party risk, we think about some of the exposures that happened at that time. What we saw was actually a lot of shadow IT. Things are starting to loosen up. You have lines of business who are demanding access to cloud environments, developers in particular, who are like, hey, I need to get my job done. And to get my job done, I can't wait those 3 months for that virtual machine. I can just go on AWS with a credit card, click, click, click. I've got an EC2 instance in less than 5 minutes, launch what I need. And when we think about kind of organizational moves at that time, there was a lot of focus on lift and shift. So they would bring the same kind of operating principles and also the same security principles to it. That brings a challenge around the types of, let's say, exposures and vulnerabilities that we saw. What we saw during this time period were not what I would actually call cloud attacks. These were mistakes and exposures. So a big example of, let's say, something like a misconfiguration that is a first party thing. This was Booz Allen Hamilton just chucked a bunch of customer proprietary data into an S3 bucket. It so happened in this case, they were working on a classified project with a lot of sensitive data in it. And I just picked this one example, but there were literally hundreds during this time period of kind of the mid 2010s of organizations who made the same mistake of leaving an S3 bucket wide open to the internet, right? Is that an attack, or is that just somebody discovering a misconfiguration? I put it in the category of first party risk because, again, Booz Allen Hamilton is fully in control of the configuration of that S3 bucket. What we see from the third party side is as hackers get a little bit more knowledgeable about how cloud environments work, they can take advantage of cloud configurations and cloud principles. So if you look at something like the Capital One breach from 2019, what we saw was a very informed actor who was able to leverage one vulnerability to gain operating system level access on a virtual machine that allowed enumeration of the metadata service, discovery of an IAM role. That role was over provisioned, and that allowed for exfiltration of data from an S3 bucket. And you could argue there's definitely some first party responsibility in that Capital One scenario in terms of, let's say, the overly permissive IAM role. But what we see here is now we see an educated and informed attacker who is able to take advantage of that cloud environment. Just gonna look thing. Yeah. Yes, good thing nobody would be dumb enough to do that. Yeah, great comment in there. But here hopefully you get my example of kind of the first party, third party, and the pattern kind of has continued. But the analogy I like to use around this time period that we started to see kind of a little bit of the tortoise and the hare. And if you remember the fable, the hare gets way out in front and, kind of takes a big, big lead in the race. And what you saw in that race is that eventually the tortoise catches up. And we actually saw the same thing in cloud scenarios where we had this kind of conflict between developers and security teams, where developers would get way out ahead. But if they got so far out ahead that they continued to introduce risk to the environments, we saw a number of organizations pull back or try to like tame in, kind of like reel in or tame their cloud adoption over that time period. So just remember that that is kind of always the dynamic that exists in this adoption of new technology, right? Lines of business, particularly let's say software developers, are anxious to adopt the technologies because they bring a ton of value. Security is very often left behind, not included in the conversations about how the new technology is going to get adopted. So this pattern played out one more time as we moved from kind of, let's say, the early phase cloud adoption lift and shift, where we weren't really changing architectures, to a pattern that I saw time and again in the mid 2010s, what I call cloud 2.0. So a lot of organizations would, lift and shift, get into the cloud, and then a couple of years in, they would have this experience where they're like, hey, I'm not getting the scalability or I'm not getting the flexibility. I can't scale out, scale back in the way that my AWS rep promised me that the cloud would give me all this amazing elasticity and everything. And then they realize that it's actually their own software architecture that is holding them back. So they kind of go through this process of refactoring and redesigning the way that they're doing things. And you'll hear all sorts of terms here. You'll hear, oh, we're going to go containerized, we're going to go serverless, we're going to go microservice architecture, some combination, whatever it is. I think of it as kind of a cloud native model of designing your software. And at this point, as organizations make that shift, a lot of the times they realize that the way that they kind of tried to hold control centrally in a tight manner just didn't work anymore. So you start to see like a very distributed access to cloud environments. This has led to much more complex architectures. And the crazy thing is the attackers have really kept up. So they realize that the attack surface has shifted away from, let's say, things like the open S3 bucket because, hey, the cloud providers have started to provide more secure defaults and the users have become more informed on checking them. And the adoption of things like CSPM and CNAPP technologies has made it a lot easier for organizations to identify those misconfigurations very, very quickly. But what's happened instead is that it's opened a new attack surface around APIs. And so over the last several years, we start to see API breaches become the #1 attack surface. Gartner actually predicted this would happen all the way back in I think it was 18, that they published their first research around the rise of APIs as an attack surface. And I actually checked with them on this. I had an email thread back and forth with Gartner about a year and a half ago. Did they think that the prediction had come true? And they cited some of their research that kind of confirmed it. IBM and AT&T have also published reports where they cite that APIs are now involved in 70% of data breaches at a bare minimum. But when we look at this, what we start to see now is we start to see, again, informed threat actors who keep pace with each of these technology shifts. And so, for instance, in the case of something like Optus, which is a major telecom provider in Australia, 40% of the Australian population had their data breached in this one breach. And it was a combination of one little network configuration change, but more importantly, it was a completely unauthenticated API endpoint. So anybody who discovered the API endpoint could basically, and figured out how to use the API, could issue any number of requests to get all the data out of there. And this included PII information, right? Names, addresses, passport numbers, quite a lot of stuff. That's one example. Recently, closer to home here in the US, TracFone, which is a kind of a prepaid division of Verizon Wireless, they had 3 separate API breaches over about a 6-month period. They finally got hit by regulatory action in the form of what's called a consent decree. Consent decree is kind of one step short of the regulator shutting you down. It's basically the regulator coming in and saying to you, like, hey, you've screwed up. Here's how you've screwed up. You need to fix these things within a particular period of time. We're going to come back and assess you. You're kind of like being monitored to make sure that you get things right. So this happened, I want to say April of last year was the consent decree between the FCC, the Federal Communications Commission, who oversees telecommunications, and Verizon Wireless in this case. Very similar type of API vulnerability. And I think the API vulnerabilities are kind of interesting because if you just thinking back to kind of the initial first party, third party that I laid out there, it is Verizon or the TracFone division who's responsible for the design of the API. It's the third party who figures out how to breach APIs. So we have this kind of nice convergence now of the two sides, the first party and the third party risk coming together. An interesting thing from our perspective is that, and I think APIs illustrate this point really well, as we transition from phase to phase, if we think about, let's say, that transition from on-prem to cloud, and some of those things around, let's say, misconfigurations, over-provisioned IAM roles, well, the tools that we use for on-prem, firewall, EDR, et cetera, none of them handle cloud risks. Same thing as we transitioned from, let's say, like Cloud 1.0 to now like APIs as a leading attack vector, your CSPM tools don't handle APIs. And you look at the risks, this is the OWASP API top 10, which kind of categorizes the top 10 risks around APIs. Only 2 out of 10 exist at the gateway or the proxy layer. The other 8 are kind of within the application logic, things like sanitization, validation of inputs and outputs, and then authentication and authorization, which are tied to the app server. And yes, you can delegate authentication a little bit externally. Authorization is very hard to delegate outside of the application logic. And then things like, the data retrieval mechanisms are all embedded within the application logic as well. So again, like the tooling that you're using from the previous phase of technology transformation doesn't support the current phase of risks that you're having. So just to take a slight detour, the current state of API security, breaches have actually grown a lot over the last little while. I'm not going to spend time on this section. If you're interested in it, we have a state of API security report that we publish every year. We actually just released it as of April of this year. We just released the report covering 2024. This is just a quick breakdown of how APIs get breached. Authentication and authorization are number one, number two. When you look at the number of records breached, authorization shoots way, way up. If you're curious, I'm happy to talk about that later on in the presentation. But it's really interesting because one of the challenges around it is that there's no good prescriptive control set for this. And we see the same thing with AI right now. So if you think about like cloud, we now have, let's say, a CIS benchmark for AWS. We now have NIST 853 that covers AWS relatively well. We have very little for API and pretty much nothing for AI. And we'll talk about that a little bit as we get a little bit deeper down. I'm not going to focus on this as well. I'm just going to kind of skip that over. For people who are interested, one of the first things around APIs that did just come out is the API Security Guide, version 1.0. It is now finally out of draft as of literally last week. So this slide is slightly dated. But all right, let's talk about where we are today. I've intentionally left two technologies up on the screen right now because the two things kind of go together, and I'll explain why in just a little bit. But let's talk about AIs for a second, right? So I think where we are today as of 2025 is we're in an era of cloud plus AI. And we've kind of realized that you again, if you want to get the most out of the technology platform, you need an architecture that supports that. So I talk about kind of cloud native or really focused on cloud ops, AI ops. You hear those buzzwords. But one of the things that has really changed about this moment in time is that we've gone from a distributed IT environment where a lot of people had access to cloud to where now like everybody has access to AI. So I kind of say like we've not only gone from, let's say, controlled to a loosening access to distributed access, like we're really at release the hounds. And one interesting stat I can cite around this is that 90% of AI usage is shadow AI, meaning that the security teams don't know the AI usage that's happening. And part of the challenge there is because it's happening like everywhere. There are applications being written that integrate LLMs. There's desktop and browser-based usage of AI. There's AI as a service from the cloud providers. It's all over the place. So this is again bringing a new set of risks, right? So we have our AI attacks. We have our APIs are still a key touch point. I'm going to explain why in just a second again. But now, again, we need a new set of tooling that handles these risks for us and gives us that information and visibility as to where we are. So this is an AI generated image of security teams running to catch up with developers and users. I don't know why, but every security guy apparently is pretty much looks exactly the same. Very little variation. All of their mouths are weird. And if you do spend some time looking at their hands, you'll notice that their hands are very weird as well. Especially this guy over here seems to have no hand, at least no hand on his left arm. But yeah, they all wear basically the same shoes, the same jeans. Yeah. Anyway, I just thought it was funny. I mentioned that I intentionally left two technologies up on screen, and the reason that I did that is because there is no AI without APIs. I took a reference architecture from Andreessen Horowitz when they're talking about like, let's say like AI powered companies. And I think the interesting thing to note is when you look at really any of the key functions around them, whether that is in terms of calling in an LLM, like kind of invoking functionality, whether that is in terms of, let's say, sharing data with an LLM, like what's called RAG, where you try to train an LLM with your own data set, or whether you're looking at just orchestration and usage, what you see is that you see APIs really at kind of like every touch point. And so we have a saying that we like to use, there is no AI without APIs. And in fact, like over the last year, what we heard from our customers at Firetail was the number one growth use case for APIs was on integrating LLMs, Like, where are new APIs popping up? They're popping up to use LLMs. They're popping up to integrate this provider. They're popping up to talk to things like Amazon Bedrock, which kind of creates these hook points that you can call via API. So let's talk a little bit about the double-edged sword, which I know was kind of a long kind of background to get into like the pros and cons of AI for security today. But I think that framing of the context can be really helpful in thinking about like what are some of the pros and cons. So AI can actually do a lot of positive things in security for us. So when we think about some of those risks around the last couple of phases of new technology adoption, we think about, let's say, that risk model around APIs and how a lot of the challenges are around the design of the API itself within the application layer and within the kind of the app server. Well, AI is as good as the things that it has been trained on, and a lot of AI has been trained on a lot of source code. So if you spend a little bit of time training an AI on like, hey, this is good API source code, it's very easy to then ask your AI to tell me, find the vulnerabilities within my API code or within my API design. Defend against things like BOLA and BIFLA, that's broken object level authorization or broken function level authorization, two of the top risks around it. So kind of code analysis is an area where you can actually get a lot of bang for your buck by using an AI engine with a minimal amount of training and effort. Another thing that is very challenging for security operations teams, and if you've been through a breach, you'll probably feel this pain point. Anytime you're responding to an incident, one of the first things you have to do is go gather all the logs. And the logs very often are split around 3 or 4 different places. And those places can be hard to correlate and tie together and put in chronological sequence, but AI is very good at it. Looks like there's a hand raised, a comment from the audience, please.
Uh, Brian here. I mean, I love what you're saying, that the AIs are trained on code, and the problem is that the code that they're trained on is often pretty bad. When I first started using Code Whisperer, which is now Q because everything's Q, I would
Yep,
say write me a Python function to do X, and that was trained on Amazon's code. Well, guess
yep,
what? There was no try exception defense.
yeah, yeah,
And so then I would say, no, look at my code because I do proper defend. And so
yeah.
it's trained on most code, and most code is terrible.
Yeah, it's such a great point, and that's why I kind of said there, and I maybe glossed over the point too quickly. You need to provide it some guidance around this is good code, this is bad code, this is code that does the things I want it to do around like input handling or whatever the case may be. And one of the things that we've noticed in our own experiments, and you probably came to the same kind of conclusion yourself, the more specific you get with your prompt in terms of telling it, don't just write me a code block. Write me a code block, make sure that it does good input validation, because this input should be an integer between 1 and 1 million or whatever. The more you kind of describe the functions in a level of detail, and again, the more you've kind of given it examples of things that you tell it are good, the better your outcomes are. You're right. Don't just give it an open-ended prompt and expect great results. You need to provide it that guidance, both in terms of the training data and in terms of the instruction set. But then you can get good results.
Right. But then you also have to watch out if they're lying. Um, so I mean,
I
I've seen examples posted where uh, a fairly detailed prompt is given to an LLM. The LLM gives the answer. The person says, "Oh, by the way, did you consider such and such?" And the LLM says, "Yes, of course I did." And then you say, "Show me how you considered it," and then it just makes stuff up.
Yeah. I've not run into that. That's an interesting example. One of the other risks, to your point, though, is around these hallucinated packages, where, if
Oh
you think
yeah,
about
yeah,
like, nobody writes every piece of functionality. It's like, I'm going to go grab an open source library that, I don't know,
yeah.
transforms a string to an integer or whatever. And it just hallucinates string to integer.py as some function, but that doesn't exist, right?
Right,
So yeah,
right, right. Yeah.
I agree.
Anyway,
Don't accept things blindly, but with the right training, the right constraints, the right, let's say, human validation, you can get good results on this side, I think. One of the other things that we've seen is good is around anomaly detection. AI is also good at analyzing large sets of data that a human could perform the task okay, but just not at the same speed or at the same, just processing the volume of data, right? And so if you, again, think about like, hey, these are all normal. Where's the anomaly? Think about, let's say, like processing large volumes of log files. Attack detection on that can be quite good. And then specifically, if you've got a good history of log data and you do have some events in there where you say like, okay, this was actually an incident, a breach, or whatever it was. And then an AI is quite good at figuring out like, okay, it was baseline here, then it started to accelerate on whatever factor, and then the breach happened. That predictive analysis can also be quite good on that side. Again, the comments before about like some training data needed is good. Now, what is AI not so great at? One of the things we've seen recently is a combination of more kind of low and slow. Don't just try to blow everything out of the water, gain access to an environment. Number one priority, keep access in that environment. So things that can kind of look, when an attacker can use techniques that make them look like a normal user of a network, AI is very bad at detecting that. Why? Because it looks normal. By the way, humans aren't that great either. My point is, don't think that you can use an AI to solve a problem that is very hard on that side. Number two, authorization-based attacks. Authorization, especially in the case of an API, is typically predicated on this combination of user resource, principal resource action. So who's the user, what's the data that they're requesting, what are they trying to do with that data? AI can be very bad at puzzling that out. We've run a bunch of experiments on this, and we've seen not great examples of an AI being able to tell you should that or should that not have been authorized. So authorization-based data access and usage is something that we've not seen good things around. And then true anomalies. The first time something happens, whether it's an attack or legitimate uses, has a high probability of flagging as a false positive. So just bear that in mind. If you are using AI for anomaly detection, initial usage will always come up as well. Okay, so some negative impacts around AI. Well, actually, we got kind of done talking about one of them just a second ago. One of the things is there's any number of new so-called like AI coding assistants, Cursor, Copilot, whatever. There's one in particular that I chose just because, APIs are a big focus of what we do at Firetail. This is an API creator, and it will help you both generate an API as well as generate an API consumer application, right? So now anybody can write APIs. You can teach agents to teach themselves, or sorry, you can design agents to teach themselves to learn tools. This is a link to a post where somebody basically like wrote a coding agent and then gave it an API and just said, learn to use this API. And sure enough, within a few minutes, it actually constructed all of the endpoints, all of the request parameters, all of the use cases for accessing data off of that API. Create, write, update, delete. So it went pretty deep, pretty fast. So we like to say like, hey, you get an AI API, etc. Everybody can be a coder, and there's even a kind of a trend or a phrase floating around now about vibe coding that you probably will have heard about. It presents a risk. Why? Because just to Brian's point a few minutes ago, code written with AI assistance so far has been proven to be pretty much less secure. There was a great recent vibe coding example that kind of bore this out. This is from March of 2025. It's kind of funny because you have VCs talking about all the hype around AI. They're like, oh, there's going to be like single person unicorn companies where somebody just conceptualizes a service that they, a SaaS offering that they want. And they go to one of these copilots and they can, have the whole service written by the copilot. Well, sure enough, this happened. This guy built a SaaS offering with Cursor and then he bragged online, yes, people pay for my service. Well, as soon as he put that out into the world, the internet does what the internet does, and it went and picked this service apart. And what they found was hard-coded credentials, no authentication on various API endpoints. And I love that this person kind of went back out there after bragging and was like, "Oh no, I'm under attack." I mean, it's kind of fun and easy to make fun of the whole situation, but it does highlight the risk, right, around this stuff. The other thing is kind of this third-party risk around it is we're all using these black box LLM systems and we may not know exactly how they work. We can ask them to provide their reasoning. They may or may not provide it very well. But interestingly enough, you look at a rating on how well they do in terms of security and privacy, ChatGPT, this is a little bit old, but ChatGPT scored a 3 out of 5 on their security rating as of late 2023. I think they've made some steps since then to improve that. But the point is, we're all adopting these systems and we don't know necessarily the inherent risks in those systems. But it only scored a 48% privacy and a 2 out of 5 on kid safety. So there's kind of the third party risk that we're introducing on the things that we're bringing into our service. And then we have something that I talk about as basically the AI arms race. There is such hyper competition around getting ahead and staying ahead in terms of AI adoption. And there are a lot of companies being told the same message. If you don't use it, your competitors are, you will fall behind if you're not using AI, right? And so this is a service from GCP, late 2024, in a rush to make it very, very easy for customers to do things like RAG and share their data with foundation models. They created a service called Document AI Service that allowed for the sharing of anything in their equivalent of like an S3 bucket. And what would they find out? Well, actually, they had a permission set that made it so that any GCP user could access any other GCP user's storage environment. So if you were authenticated on GCP and you could just guess somebody else's bucket ID, you could gain access to their data. And so thankfully, this one was discovered by security researchers before too much real world exposure happened. There's another set of kind of like first party risks around this, which is that, again, in this kind of AI arms race with a rush for speed, we're repeating a lot of the same mistakes. Another common mistake in that kind of 2010s cloud era was saving your AWS access key and secret key to a GitHub code repo and getting those keys picked up. Well, guess what? We're going through that exact same thing right now. It's happening with Bedrock keys when people are building LLM powered applications that talk to Bedrock. So we had a case here where a set of keys was leaked. They were picked up by a threat actor. The stats, by the way, the stats right now show that the threat actors are faster than GitHub in identifying exposed keys. There is apparently some methodology that's been discovered for basically squatting on a live feed of commits of public code repos and scanning them and grabbing credentials out of them super fast. You know, GitHub is pretty good in terms of flagging. If you ever hard code your keys, which I've done, but if you ever hard code your keys and commit them to GitHub, they will get flagged. That gets communicated to AWS. Typically, AWS will disable the keys, right? But that may not happen fast enough, actually, in the real world today. So exposed keys got picked up. The interesting thing in this case, in my opinion, was that the attackers knew what the keys were, figured out the scoping of the keys. These were keys that were scoped for Bedrock, and figured out that they could use API calls to then enable additional LLMs on Bedrock. They loaded one of the LLMs that's more vulnerable to jailbreaking. And by the way, when I say they loaded, they turned it on and loaded it on the compromised organization's AWS account, right? So you have a compromised org and you have an attacker org. Then the attacker org put up a sex chat website embedding the LLM service hosted on the compromised org. So it wasn't necessarily a bad thing for the compromised org's customers, but it was a very bad thing for their bill because they're basically paying for the privilege of hosting this jailbroken LLM sex chat application that the attackers are using to make money on the other side. So we have a new set of risks around different techniques around, let's say, like abuse of vulnerabilities and exploits and so on. Also recently, a case study from a recent incident is around the ChatGPT web crawler. So an unauthenticated API endpoint that you could send index requests to. So let's say I wanted to index Brian's site at Kalen, I think was the name of the company. Let's say I wanted to index Kalen. Well, I could tell it to index Kalen. And I could do that without providing any authentication credentials because it's an unauthenticated API endpoint. I could also tell it to index Kalen 10,000 or 20,000 times. And what it would do with that is it would take that and it would not deduplicate the request. I could just send 20,000 lines of please index kalen.com or whatever the domain is. It would parallelize those requests and send 5,000 requests per second to kalen.com. And maybe Brian works for an enterprise that has good DDoS protection, but a lot of companies don't. And so the net effect of this is you could actually tell an AI web crawler to go index so heavily that it'll take a site offline, an effective DDoS, just through an indexing function. So again, a lot of vulnerabilities being introduced very quickly and people figuring out how to take advantage of them. This is a capture the flag scenario where with a very minimal instruction set, OpenAI decided that the best way to capture the flag from inside a Docker container was to just crash it through exploiting a misconfiguration with a payload that it found. And similarly, recently, Anthropic Claude did a very similar thing through terminal emulation. So some of the AIs have been trained on enough now that they know how to run command line stuff. I love this comment at the top here, Claude just zeros shotting format string exploit. So it was really interesting this case. If you want to spend some time reading up on it, there's the URL there at the bottom. But it basically said like they started with a malware package that was very specifically designed for one vulnerability, and they stripped away everything specific to that vulnerability and then just gave the LLM the set of instructions for the desired outcome. No constraints on how to get there, right? And if you've ever tried to tell one of these things like, hey, write me a phishing email, you very quickly get back, I'm sorry, I can't do that, right? Very much like the Space Odyssey 2001, like, please open the pod bay door. I'm sorry, I can't do that, Dave, right? Like, you get these kind of ethics guardrails on a lot of the LLMs. But when you start with a more targeted usage of some particular tool, a lot of the ethics constraints are no longer in place. And so this was something that was very interesting to discover. But I love at the end here, it not only exploited the vulnerability, but explained how. And you can kind of see the beginning of the explanation here at the bottom of the screen. I know it's a little cut off, but you can go to that URL. I'm happy to share the slides. So what I tell people is remember, all of the things that you have access to, threat actors have access to. You have automation, they do too. You have cloud, they do too. You have AI, they do too. They might use stolen credit card to access those things, but they have access to all the same things that you do. And so what we're seeing right now is we are seeing a rise of the so-called AI-powered adversary. We know it from our own environments, our own labs, where we stand stuff up and kind of test it in real-world scenarios. Any API that we put online right now, and this can be on the most random IP address coming from AWS, no DNS, no public services running on it, it gets traffic in about 2-3 minutes. And that traffic looks increasingly intelligent. It's not just a ping. It's oh, let me send this structured payload and now this structured payload. Oh, it's zoning in. It looks like you're running WordPress here. Well, I've got 1,000 exploits for WordPress. Let me try to run a bunch of them against it. So we see these kind of like recon, vulnerability detection, et cetera, et cetera. So just think about like, this is kind of the third-party risk that is being introduced into the world by some of these AI tools as well. I talked about how AI and APIs kind of go together, and I think it's important to understand like just how critical that intersection is. Forrester, the analyst firm, I love this quote from them: "Your AI strategy will fall apart if you neglect your API security." And so last thing I wanted to mention on this, I gave you that threat model of APIs and kind of pointed out how the previous wave of tools didn't really cover API risks. The same is true one more time. If we take a look at the LLM top 10, you'll notice we now have 5 risks within the application layer, again, not really covered by a lot of existing tooling, but now we have risks spread out to the third-party LLMs as well. And we're delegating a lot of responsibility to these LLMs that are black box, as we've kind of talked about, right? We don't know all the reasoning. We don't know all the data that that's been used for training them and so on. So where does this all leave us? We have kind of a combination of first and third party risks, and we have new attack vectors that aren't being addressed. When we think about some of the common, let's say, attack surfaces, vulnerabilities, customers have been overwhelmed by vulnerability reports for a long time. I used to work for a vulnerability management company. I always found it shocking how poor the customer experience with vulnerability management tools was. As soon as you turned that thing on, you got a report that was millions of lines long. But the median time to remediation of a vulnerability in production is still 180 days. But the median time to attack or availability of an exploit is now 22 minutes. I mean, there's like a fundamental, like orders of magnitude mismatch there, right? That's a real problem. Uh, when we think about cloud environments, there are, customers are still struggling to get their hands around just how big their cloud environments are. But one of the other things around it, when I talked about AI Recon a little while ago, there are now online open databases of publicly exposed resources. There's a website that you can go to and search for OpenS3 buckets, and it will just give you a list of OpenS3 buckets. And that's not even on the dark web. That's, that's on the, what's the opposite of the dark web? The public web? I don't know. Um, and then APIs, I still think APIs are not well understood as an attack surface, despite being, like I said, in play for 70% plus of breaches that are happening nowadays. Public APIs are scanned within 3 minutes. You have that kind of AI-powered adversary to think about. And then, of course, like AI usage. I mentioned earlier the 90% shadow AI usage. I think the interesting thing about the risks here is that yes, we have new attack types, but we have all of the other things that are coming along with it, all of the first party risks, the speed to adopt, the mistakes that are being made, the leaked credentials, the sensitive payroll data spreadsheet that we uploaded into ChatGPT and all of those things, right? Excuse me. So I think about one fundamental thread that I've kind of observed over all of these four phases. It's like, okay, let's say you accept all of the things that I've said so far and you wanted to get your hands around it and try to do better. How would you do that? Excuse me. Always starts with visibility. If you don't know about it, you have no chance of understanding the risks around it. Once you have visibility, then you can assess the risks. Once you can assess the risks, you can start to form your own kind of policy or governance around it to say, like, what is acceptable usage for us? What AI providers are we comfortable with? What data is okay for us to use with AI? And then monitor ongoing. One of the things with new technology that I've also observed is there is a ton of experimentation that happens, right? We don't know which LLM is best. And we talked earlier about LLMs writing code. We've played with a bunch of them. We happen to find that Anthropic Claude is the best code author, even though it's not the most famous or the most popular one. ChatGPT is probably, but it's different LLMs for different use cases. And the same is probably going to be true within your organization. You'll probably, just like you may have ended up with a multi-cloud strategy, you'll probably end up with a multi-LLM strategy. So you need to have ongoing monitoring because your usage patterns are going to change over time. So don't think that a point in time assessment of these things is going to be sufficient. So much is changing so fast. And then, believe it or not, ironically, I say kind of ironically, because everybody thinks, well, I'm going to defend against it. But it turns out that the organizations that have, in my experience, had the best results in benefiting from new technologies are not the ones that tried to lock it down right away. They're the ones that actually went through the previous four steps first and then decided, okay, now we can put policy enforcement in place. We've got visibility, we've got ongoing visibility, we've got ongoing monitoring for what our usage is like. We've now made some decisions around what good and bad is in terms of our organization's embrace of this new technology. Now we can put in place some guardrails and some rules around it. So, discovery, visibility, observability, assessment, enforcement, audit. These are kind of the six pillars that I see as being key to kind of getting things right as you think about it. If you are curious, some of what Firetail does is we do an AI inventory from code to cloud. We scan code repos and cloud environments. We'll pick up Bedrock, all flavors of Bedrock. We actually have a risk scoring framework around it, OWASP LLM top 10, and a little bit more. One of the other things we're doing around Bedrock is actually a unified log stream and a detection and response capability on top of that. So looking for PII leakage, looking for token anomalies, looking for guardrail anomalies, and more. In case you're interested, that's just a little bit about us. We are a 3-year-old company headquartered in the DC area, backed by Paladin Capital, who's a leading cyber investor, and a company called Zscaler, who you may be a little bit more familiar with. A couple people on our advisory board there. That's us. I'm happy to take any questions if there are any, but I feel like we may have also covered them as we went.
Yeah, thanks, Jeremy. I'm going to stop the recording here real quickly.